Okay, so let's look at another pressure gauge device, a barometer. Okay, so the way a barometer works, again, you've got this liquid and you have a difference in height, just as we saw with the manometer. And so what happens is you take a long, thin tube and you fill it with some liquid. Okay, I think the common liquid that they use is mercury, and you fill it up and you shut that end. Okay, you close it, then you flip it around and you put it inside this tub, inside this reservoir of the same liquid, right? The same liquid in there, the liquid there and there is the same. And what happens is, then you open this covering and you let the water flow out into the reservoir until it's in balance and it's not flowing anymore. And what happens is you form a vacuum here. Okay, so all the water or the mercury or whatever was up until there, okay, and then you allowed it to flow out and then it created a vacuum. So the pressure at this point is 0. The pressure there is 0, and the pressure there on that surface is atmosphere. Okay? Does that make sense? So, if we consider equation 18.6, if you remember, equation 18.6 was the pressure at point 1, whatever that was, plus rho g y1 is equal to the pressure at point 2 plus rho g y2. Okay, that was equation 18.6. Now, if we consider this to be point 1 and that to be point 2, then the pressure at point 1, right, we know is atmosphere. And if we take y1 to be 0, kind of a reference point, we take y1 to be 0, then we're going to get on the left hand side of this equation, we're going to get P atmosphere plus 0. Okay, and then what are we going to get on the right hand side of the equation? We're going to get P2, which is 0, plus rho g y2, which is now simply this height. Okay, so why do we use a barometer? To measure atmospheric pressure. So P atmosphere is simply equal to the density of this fluid times gravity times the height that it rises to. Now you can imagine, if the atmospheric pressure increases, right, then it presses down on the surface more, and this will go higher. Okay, if the pressure decreases, then this will fall out more, right, come out more, and this will be raised. So it's a way of measuring the atmospheric pressure. Okay, so if we know the mass density rho of the liquid, we can determine atmospheric pressure by measuring the height h of the liquid in the tube.